Alright, I just have a few more problems I want to look at with you as far as this first section of limits goes. And what we're going to do is we're going to sketch this graph, and then we're going to identify the values of C for which the limit exists. So we're looking to see if there's anywhere where a limit does not exist, basically. A lot of people have difficulties with these piecewise functions, that's what they're called. But don't overcomplicate them. This is just saying when x is less than 0, the function sine of x. So we're talking about over here in this domain. So when I plug in negative pi over 2, the sine of negative pi over 2, okay, that's the sine of negative 90 degrees, is negative 1. So it would be down here. Then you should know that the functions of sine and cosine go up there, those periodic functions from pre-calc. So if you plug in sine of 0, you get 0. Now, some people are going to ask me, why am I plugging in 0 when it says it's less than 0? Because I want to know what happens as it gets really, really close to 0. So I'll put an open dot here because it's not actually part of this graph, but it's getting closer and closer to it, and it's going to be going up like this. It's that periodic function. So that's this section here. I'll change colors so you can now see 1 minus cosine x. So it says from 0 to pi. So we're going to plug in 0. So I have 1 minus cosine of 0. The cosine of 0 is 1. And so I have 1 minus 1, which is 0. So it actually fills in this dot, which means there is no hole here in this graph anymore. From there, I'm going to plug in pi over 2. So 1 minus cosine of pi over 2. The cosine of pi over 2 is 0. 1 minus 0 is 1. So it's coming up here. Then from at pi, 1 minus cosine of pi. Cosine of pi is negative 1, so it's going up to 2. I need to extend out my graph just a little bit here. I'll just say that 2 is up here. Alright. And I did use a colored in dot because it was less than or equal to. I went ahead and colored that in. So it's coming up here. Remember, this is just a sketch. This may not be exactly how it looks. Just keep that in mind. This is a sketch. I'm just sketching it. The last part then is the cosine of x. Well, the cosine, I'd be plugging in pi. The cosine of pi is negative 1. So that's coming way down here. And I'm using an open dot on it because it's not greater than or equal to, it's just greater than. So I'll go ahead and find out what is the cosine of 3 pi over 2, and the cosine of 3 pi over 2 is 0. So I'll put a colored in dot up here, and it probably, has some sort of curve to it. So this is the sketch. Now we're supposed to identify those values of C for which the limit exists. We're talking about exists, so the easiest thing to do, and I'll write the answer right up here, is that the limit exists everywhere except one spot. Okay, from the right and from the left, it exists everywhere except here at pi, except at x equals pi. Okay, on this next problem, what it's asking you to do is to find the domains. We're looking at the x values. Domain means x's, and we're going to look at the graphing calculator, and we're going to see if we can detect an error in the domain. Why is it important to examine a function analytically as well as graphically? Those are all questions we're asking ourselves. So we're going to find the domain of this. Remember, domain are x values. So I'm looking for, are there any bad x values? As I look at this analytically without looking at the graph, hopefully you're noticing that you can't have zeros on the bottom of the fraction. Can't have zeros on the bottom of the fraction. Also, in domain, you can't have negatives underneath the square root. So those are the two things you're looking at as far as domain is concerned. There are no square roots in this problem, so we don't have to worry about that. So the domain would be all values of x. Domain is all values of x, or all reals. X is all reals, except x cannot equal 1 and 3. Now let's go and look at this graphically, and I've already put it on my graphing calculator. And I'm going to slide this down because right now it looks pretty good. Oh, there's the part where it does not, the domain does not exist. It looks like there's a vertical asymptote. As you go along the way here, at 3, you're expecting maybe to see another vertical asymptote, and there's nothing there. Well, what I'm going to do is I'm going to trace this real quick. And as you can see right here at 3, it looks like things exist. But it's just not showing you that when you plug 3 in for this function, you do get 0 on the bottom. And so it's not showing that does not exist part. What there is a hole. How can you tell that analytically? Well, if something will cancel with the top, so see how these two cancel? You actually created a hole there, not an asymptote. So there's an asymptote at 1, and we're going to discuss this much more in the next coming sections, but there's a hole at 3. So why is it important to examine it analytically as well as graphically? Because the graphic models doesn't always show those holes.